So this is going to be a little bit of a challenging problem, mostly because of the 4. In order to change one function to the other, I need something like sine squared and cosine squared. Yet when I square this, I'm going to have a 16 sine squared. But there's not really any way around it, so just start doing the algebra. Square both sides. So on the left-hand side, there's going to be cosine squared. The middle term is going to be this times this and then doubled. So that's going to be 6 cosine of x and then a 9. On the right hand side, it's going to be 16 sine squared x. Everything over here is cosine, so I should probably change this. Sine squared is equal to 1 minus cosine squared. Recopy the other guys on the left-hand side. And then distribute. So this is going to be a 16 and a negative 16 cosine squared. All those things need to be moved over to the left-hand side. So subtract 16 and do the opposite, add 16 cosine squared. So add 16 cosine squared and subtract 16. So there's 17 cosine squared plus 6 cosines, and then negative 7, and now it's equal to 0. I doubt that's going to factor, so use the quadratic formula. It's going to be that cosine of x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So then it's in the radical, it's 36, and then 2 negatives will make a positive 28 that gets multiplied with 17, so the square root of 512. So the cosine of x is equal to negative 6 plus or minus the square root of 512 divided by 34. And the square root of 512 is not a perfect square, so I'm going to type the whole thing in the calculator at once. Negative 6 plus the square root of 512 divided by 34, and then do the same thing with subtracting. So then we've got cosine of x is equal to a 0.489, or cosine of x is equal to negative 0.842. And then take cosine inverse. So cosine inverse of a 0.489 in radians of 1.06, and then cosine inverse of negative 0.842. X is equal to 2.572. And then graph the original problem and see cosine of x plus 3 equals 4 sine of x. And then see, because sometimes when you square both sides, it introduces answers you don't really need, that aren't true. So we need to check. So there are the graphs. There are 2 places where they intersect. And let's see, trace and try out a 1.06. That seems to be the first place that they intersect. And then what about a 2.572? Huh, very nice. Worked out, though we didn't have to go and get any more solutions. Those are the 2.